Okay, so here's the lab. We have the different stations. Station 1 sits here and says, observe the book on the table. Do not touch the book. Do not move the book. Draw a free body diagram on your lab sheet to make sure that you label all of the forces that are being applied to your book. Identify the forces, meaning you need to include what type of F is that. Write 1 to 2 sentences of your observation of the station. It says here, identify if that station is either balanced or unbalanced. Identify whether or not it is accelerating or not accelerating. So a yes or a no. And then if it is accelerating, what direction is it moving? So let's go ahead, and here's the lab paper. You're going to make sure you have your name on it. Here is station 1A. You should have this printed out already. Draw your free body diagram here. Your 2 sentences, or 1 to 2 sentences, a B or a U if it's balanced or unbalanced, a yes or a no if it's accelerating, and if it's accelerating, draw the direction. If it's not, leave it blank. Here is station 1A. It's just a physics book sitting there on the countertop. Okay, I'm going to keep going. You're more than welcome to pause any station and rewind it whenever you need to when we get to that station. But this is station 1B. Let's read the directions for 1B. 1B says here that we need to hold a tennis ball 1 meter above the ground, drop the tennis ball. Then it says over here, and observe what happens when it's halfway. That's the key word. Halfway between your hands and the ground. Draw a free body diagram on your lab sheet of the ball falling to the ground when it's halfway to the ground. Identify and label all of the forces that are acting on that tennis ball. So include all of the F's. What type of F is it? Is it F sub T, F sub A, F sub G, F sub F? Write 1 or 2 sentences that explains what's happening at this station, which is 1B, and then go ahead and identify if it's balanced or unbalanced, write whether or not it's accelerating or not, and then identify the direction if it is accelerating. So again, we're going to go to our lab paper on 1B. We're going to go ahead and fill out that row, okay? So here's my tennis ball, here's my meter stick. I'm going to go ahead and set up my meter stick. There's the meter side. And so all we're doing is we're drawing the free body diagram, but we're going to draw it when it's at halfway. So at the 50 centimeters or the 0.5 meter, okay? So if here's my meter stick, I'm going to have the ball here at this location when it's halfway. So let me go ahead and move the camera a little bit lower. At this position is where you're drawing the free body diagram. Ready, set, drop. Okay, we're drawing that free body diagram, and we're not going to draw it when that ball bounces back up or when it's in my hands, but halfway is the key word. Let's go to station 2A. Station 2A states that you're going to place a Hot Wheels car behind a piece of tape, which is the starting line on the table. It says here, stand at the end of the table and shoot the dart gun at the car and make the car move. Draw the free body diagram of the car in motion on your lab sheet. Make sure to label all of the forces that are being identified during this station. Make sure to write 1 to 2 sentences of your observation. Is it balanced or unbalanced? Determine if it's accelerating, and if so, what direction is it accelerating? Okay, so let me go ahead and move this paper out of the way for station 2A. You're going to do that over here on page 1 of your notes, of your lab paper. And here's my starting line. Here is my car. Here's my dart gun. Now my dart gun actually has Velcro to the end of it, and then I have Velcro at the end of the car, so that way it's going to attach to it and cause it to go. So let's see how strong this little tiny Nerf gun is. Let me see. I missed it. That's horrible. Let's go ahead and try this again. All right. Let me get this dart gun. It is not easy trying to video and hold it at the same time. Let's try it again. Ready, set. There we go. So it worked. I didn't hit it level, but let's go ahead and shoot it level this time, and I'm going to video it horizontally so that way you can see it actually going. Make sure you actually hit it because I wasn't able to hit it the first time. Ready, set, go. Okay, so you're drawing that car in motion while it's driving. So the dart hit it and then it starts to move, right? In the motion of it moving is when you're going to draw the free body diagram. Let's keep going. We're going to move over here to station 2B. Let's read station 2B. It says here, observe the ping pong ball that is attached to the ring stand. Here's my ring stand. Okay. Oops, let's move that out the way. It says here, oops, I moved it. Do not touch it. Identify all of the forces that are acting on the ping pong ball. Draw a free body diagram on your lab sheet, 1 to 2 sentences, balanced or unbalanced, whether it's accelerating, and if so, what direction is it accelerating? Here's the ping pong ball. I accidentally touched it, so now I'm trying to stop it from moving. Right? So, looking at the ping pong ball that is attached to the ring stand is what we're looking at right here. That is what you're drawing. Okay? And you're going to put that on station 2B, which is going to be page 2 of your lab paper over here. Station 3. Station 3, it has some cards. It says on a piece of paper, label it A through X. So I labeled it A through X. Now open the baggie, it says, and sort the pictures. Decide if the pictures are demonstrating Newton's first, second, or third law. You only need to write a 1, 2, or 3 next to it, and then staple it to the back of your lab paper. So it is due as an attachment. Okay, so let me go ahead and get those cards ready. I'm going to have them, I'm going to put them right here in front of you. It's going to be a little quick, so if you need to, then you pause it so you can decide if it's a first, second, or third law. Okay, here are the pictures. Let me move the camera down a little better. A, B, C, D, E, F. We will go over these in class. G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, and X. Okay, so please, if you needed to, pause the video or rewind it if you need to, so that way you can determine if it's first, second, or third law. And that was station 3A. Attach that paper to the back of your lab paper. 3B, get the changes in motion paper completed and staple it to the back of your lab paper. Here is the paper. It is attached to your lab paper for you to print out and complete and attach it. That is station 3B. Let's continue to station 4. Station 4 says answer the questions that are here on the table. Staple it to the back of your lab paper. Station 4 looks like this. Please answer the questions and attach it to your lab paper. If you're missing a page, then you're not going to get credit for that. Let's go to station 5. Station 5 has an A and a B. Okay, so let's read station 5. Station 5 says, using the string attached to the yo-yo, make the yo-yo go up and down. All right, draw a free body diagram on your lab sheet. For 5A of your lab sheet, use the motion of the yo-yo going down. Draw the free body diagram of the yo-yo going down. For 5B on your lab paper, use the motion of the yo-yo going back up to your hand. Identify and label all the forces acting on the yo-yo. Write 1 to 2 sentences. Identify whether it's balanced or unbalanced on 5A and B, and if it's accelerating, yes or no, and what direction. Okay, so let's go ahead and let's do that. I've got my yo-yo over here. So here's my yo-yo. Let's see. Oh, snappers, Miss Munson. I couldn't even get that one to work either. Give me a moment. Let's wind it back up again. All right. So, line this yo-yo back up. Another failed attempt. It's okay. So, let's see. Up, down. And I can't get it back up again. That's pretty bad, huh? Well, we saw it the first time, and then we saw the down a few times. It kept on going down, right? That up was not too easy. So let's go ahead and one more time just in case. If not, rewind it because I did get it the second time. All right, so here's my yo-yo. Down and up. Down and up. So for part A, 5A is going to be the yo-yo going down. 5B is a yo-yo traveling back up. Okay, let's finish that station. Station 6. Station 6 says here, using the string attached to the black motion car, pull the car to the top of the ramp. Here's the motion car. I actually put more mass on it to make it a little heavier. Here's a string attached to it, and here's the ramp. Draw a free body diagram on your lab sheet. Identify and label all of the forces acting on the car when it's being pulled up the ramp. Identify whether it's balanced or unbalanced. Write 1 to 2 sentences, whether it's accelerating or not, and if so, what direction. So let's go ahead and let's see if I can move this a little back so that way we can see the whole view of the car. Oops, I'm dropping my whole phone. I apologize. There we go. Okay, so here's the ramp. Here is the motion car. Here's the string, hint, hint, attached to it. And the part where you are going to draw it is going to be right here while I'm pulling it up. Let's do it again. At this point right here while it's going up the ramp. So at the point of me pulling it up and it's moving up is where you're drawing for station 6. Station 7 says here you're going to answer the questions that are on the paper that's here on the table, staple it to the back, and make sure you attach it to your lab. This is only 2 questions here. I just left so much space for you so that way you can answer it. Turn the page, you have some more free body diagram drawings. This is a Newton's gravitational equation for you to work out. Okay, so again, this is due on Sunday. Please use your time throughout the week. That way you're not waiting to the last minute to get it done. All right, have a great day.